Hello there, and welcome back to Bedtime Science. I'm really glad you're here tonight. The night sky is one of the oldest experiences available to a human being. Long before cities, maps, telescopes, writing, agriculture, clocks, and electric light, people looked upward into darkness and found a ceiling that did not behave like a ceiling at all. It moved. It returned. It changed with the seasons. It carried the moon through phases, the planets through wandering paths, and the stars through a slow rotation that could be used for direction, ceremony, memory, and wonder. The sky was not a decoration above life. It was part of life. Even now, after satellites, observatories, spacecraft, and deep images from space telescopes, the naked night sky still has a strange power. It is immediate and ancient at once. The stars seen by unaided eyes are not images on a screen. Their light is arriving directly, after years or centuries or thousands of years of travel, to fall through the atmosphere and enter a pair of eyes on Earth. A person standing quietly under a clear sky is not looking at a representation of the universe. They are receiving the universe itself in the form of light. The first quiet wonder is that the night sky is not really a single thing. It is a layering of distances and times. The moon is nearby in cosmic terms, about 250,000 miles away. The planets are worlds moving around the same sun as Earth. The stars are suns scattered through the galaxy. The Milky Way is the galaxy seen from inside its own disk. The Andromeda Galaxy is another vast island of stars, more than 2 million light-years away. Beyond that are galaxies too faint for eyes, then deeper fields, then the oldest light detectable by instruments, stretched by expansion into microwaves. This means the sky has no single present tense. The moon is seen as it was just over a second ago. Jupiter is seen as it was tens of minutes ago, depending on where it is in its orbit. Sirius is seen as it was more than 8 years ago. Deneb, depending on the distance estimate used, is seen as it was thousands of years ago. The Andromeda Galaxy is seen as it was before modern humans existed. To look up is to let many pasts arrive together. The sky is a clock with no hands, showing time by distance. Tonight, we move gently through the quiet wonders of the night sky, stars and planets, moon and Milky Way, eclipses and meteors, auroras and dark nebulae, ancient clusters and distant galaxies, telescopes and naked eyes, and the simple human act of lying beneath a turning universe and letting its scale become calm. Begin with naked eye stars. Under a dark, transparent sky, the unaided eye can see several thousand stars at once, though the exact number depends on latitude, eyesight, altitude, air clarity, and artificial light. Across the whole celestial sphere, the total visible to the human eye is often counted in the thousands, not millions. This is important because the emotional impression of infinity comes from a limited number of points arranged across a very large dome of darkness. The eye sees enough to be overwhelmed, but not enough to show the full population of even the local galaxy. An observer who gives the eyes time can watch the sky slowly fill. Faint stars appear after bright ones. The first pattern becomes many patterns. What seemed like a few scattered lights becomes a landscape of brightness, color, and density. This detail matters because it turns looking into understanding. It connects the visible sky with motion, distance, chemistry, gravity, atmosphere, or time. Nothing in the night is merely decorative once its relationships are known. A point becomes a star, a haze becomes a galaxy, a dark patch becomes dust, and a familiar pattern becomes a doorway into scale. Brightness has its own old language in the magnitude scale. Astronomical brightness is described by the magnitude scale, a system inherited from ancient sky watching and refined into mathematics. The brighter an object appears, the lower its magnitude number. Sirius has a negative magnitude because it is so bright, while the faintest stars visible under ideal dark skies are near magnitude 6. 5 magnitudes correspond to a brightness factor of 100, so a small change in the number can represent a large change in actual brightness reaching the eye. This backward-seeming scale is a reminder that science often preserves history inside its units. The sky was first measured by people looking, comparing, remembering, and ranking before detectors could count photons precisely. For the person under the sky, the lesson does not have to arrive quickly. Astronomy can begin as recognition, then become curiosity, then become a quiet habit of returning. The same object seen again on another night is not quite the same, because the observer has changed. Knowledge adds depth without taking away the calm. Twinkling is one of the first signs that the atmosphere is part of the view. Stars twinkle because their light passes through Earth's moving atmosphere. A distant star is effectively a point source, and as its narrow beam of light crosses layers of air with changing temperature and density, the beam is bent slightly from moment to moment. The eye receives these tiny changes as flickering, sharpening, color flashes, and motion. The star is not trembling. The air above the observer is moving. Planets usually look steadier because they show tiny disks rather than perfect points. Atmospheric disturbances are averaged across that small disk, so the light changes less dramatically. This is one of the first subtle differences a careful sky watcher can learn. This is the rhythm of stargazing. First the eye receives, then the mind organizes, and only afterward does the science open. A simple sight becomes part of a larger system. The sky remains beautiful, but the beauty becomes more exact, held by causes rather than by vagueness. Even the quality of the air changes what the sky becomes. Astronomers separate two qualities of the atmosphere: seeing and transparency. Seeing is the steadiness of the air, important for sharp views through telescopes. Transparency is the clarity of the air, important for faint stars, galaxies, and the Milky Way. A night can be clear but turbulent, giving bright stars that dance wildly. Another night can be steady but slightly hazy, making planets sharp while the faintest objects fade. The ground-based sky is never space alone. It is space filtered through weather, dust, humidity, heat rising from buildings, wind, and altitude. Every night is a different optical instrument. In this way, the night sky teaches scale without making it harsh. The facts are large, but they arrive gently. They come as pale light, slow motion, soft color, and repeated return. The mind can rest inside them because they do not demand speed. They simply wait to be noticed. Dark adaptation is one of the gentlest parts of stargazing. The eye becomes more sensitive in darkness over time. Pupils open quickly, but the deeper change happens inside the retina as rod photoreceptors regain sensitivity. After 20 or 30 minutes away from bright light, faint stars and the Milky Way can become far more visible. The sky has not changed. The observer has changed. Darkness becomes readable only after the body has adjusted to it. This is one reason a phone screen can ruin a stargazing session. A moment of bright light can erase much of the sensitivity that took time to build. The night asks for patience before it gives its full detail. The important thing is not to memorize everything at once. It is enough to let one idea settle. The sky has always been learned slowly by people who watched, forgot, returned, compared, and watched again. Patient attention is part of the method. Faint objects also teach the trick of averted vision. The center of human vision is excellent for detail and color in daylight, but it has fewer rods, the cells most useful for dim light. For faint objects, looking slightly to the side can make them easier to see. This technique is called averted vision. A faint cluster, galaxy, or nebula may disappear when stared at directly and reappear when the gaze rests nearby. There is a quiet lesson in this. Some things in the sky are not found by force. They are found by learning the limits of the eye and working with them gently. What appears still is often moving. What appears small is often immense. What appears empty is often full. This reversal is one of the deepest pleasures of astronomy. The night sky keeps offering ordinary sights that become extraordinary when understood. Light pollution changes this experience deeply, hiding the Milky Way from a large part of humanity. Artificial sky glow from cities and towns brightens the background sky, lowering contrast until faint stars and diffuse objects vanish. The loss is not only an inconvenience for astronomers. It changes culture, ecology, and the human relationship with darkness. A child can grow up under a bright urban sky and never see the galaxy that contains the solar system. The night sky is a shared inheritance, but access to it is now uneven. A truly dark sky has become, in many places, something people must travel to find. Darkness itself is also habitat, not emptiness. It is a condition many living things need. Artificial light at night can affect migrating birds, insects, amphibians, sea turtles, bats, plants, and human sleep rhythms. Fireflies signal in darkness. Moths navigate by natural light. Sea turtle hatchlings can be confused by coastal lighting. Birds migrating at night can become trapped by bright urban glows. The stars disappear upward, and the night world is disturbed downward. Protecting darkness is therefore not only about astronomy. It is about allowing nocturnal life to continue using the environment for which it evolved. The Milky Way begins as a pale band and then becomes a galaxy, appearing as a pale band because we are inside a flattened galaxy, looking through its star-rich disk. The glow is the combined light of countless stars too distant and crowded for the naked eye to separate. Under dark skies, it has texture: bright star clouds, dark lanes, knots, and soft, uneven brightness. It can look almost like weather, but it is a structure of stars, gas, and dust on a scale the body cannot feel. To see the Milky Way clearly is to realize that the solar system is not floating alone. It is embedded in a vast stellar city, and the night sky is the city seen from within. Dark nebulae reveal that darkness can have structure. The dark regions in the Milky Way are not empty holes. They are dense clouds of gas and dust blocking the light of stars behind them. The Great Rift and the Coal Sack are famous examples. In some southern sky traditions, the dark spaces themselves form figures, such as the emu in the sky in Aboriginal Australian astronomy. This is a powerful reversal of one habit. Meaning can be found not only in points of light, but in the darkness between them. A dark nebula is shadow on a galactic scale. It hides stars, but it can also be the raw material from which future stars may form. Constellations have a special quietness because they are partly sky and partly mind. Constellations are human patterns placed on a three-dimensional sky. The stars of Orion, Scorpius, Cygnus, or Taurus usually do not form physical groups in space. They only lie in similar directions from Earth's point of view. From another star, the patterns would change or disappear. A constellation is therefore both real and not real. Real as culture, navigation, memory, and map. Not real as a physical outline in space. This makes constellations beautiful in a distinctly human way. They reveal not only the stars, but the pattern making mind looking at them. The modern map adds another layer. Modern astronomy uses 88 official constellations as regions of the sky, standardized by the International Astronomical Union. These regions are practical, like countries on a map. Every point in the sky belongs to one of them. Their names often come through Greek, Roman, Arabic, and European traditions, but human sky traditions are far more varied than the official grid. Different cultures have drawn different figures from the same lights. The scientific sky and the story sky can coexist. One gives coordinates, the other gives memory. Both are ways of finding a place in darkness. Asterisms make the sky easier to enter. Some of the most familiar sky patterns are not official constellations, but asterisms. The Big Dipper is part of Ursa Major. The summer triangle joins Vega, Deneb, and Altair from 3 different constellations. Orion's belt is a small pattern inside Orion recognized almost everywhere. Asterisms are useful because they are simple anchors. Once one pattern is known, the surrounding sky becomes easier to learn. Learning the sky often begins with a single familiar shape. Recognition spreads outward from there, star by star, season by season. Polaris shows that usefulness is not the same as brightness. Polaris is valuable not because it is the brightest star, but because it lies close to the north celestial pole. As Earth rotates, stars appear to circle that point, while Polaris remains nearly still. In the northern hemisphere, the height of Polaris above the horizon is roughly the observer's latitude. For travelers, sailors, and sky watchers, that steady position has made Polaris one of the most useful stars in human history. The North Star is a lesson in position over brightness. It guides not by dominating the sky, but by staying close to the point around which the sky seems to turn. Precession makes even the North Star temporary. Polaris is not permanently the pole star. Earth's axis slowly wobbles in a cycle of about 26,000 years, a motion called precession. Because of this, the celestial pole traces a circle among the stars. Thuban and Draco was once closer to the pole. Vega will become a future northern guide. The sky seems fixed across a human lifetime, but over millennia its geometry changes. Even the star that represents steadiness is part of a slow motion. Astronomy often reveals movement hidden inside apparent permanence. The moon offers the nearest lesson in celestial geometry. The moon is the closest great wonder of the night sky. Its phases come from geometry. Half the moon is always lit by the sun, but the fraction visible from Earth changes as the moon orbits our planet. New moon, crescent, quarter, gibbous, full, and back again are not changes in the moon itself. They are changes in angle, light, and perspective. This monthly rhythm gave human beings one of their first natural calendars. The word month still carries the memory of the moon. The lunar surface is quiet but heavily written by time. The moon's bright highlands are ancient, cratered crust. Its dark maria are basaltic plains formed when lava flooded large impact basins billions of years ago. To the naked eye, these dark plains create familiar patterns: a face, a rabbit, a figure carrying wood, a toad, or other shapes depending on culture. Through binoculars, the moon becomes more physical, with crater rims, shadows, mountain edges, and bright rays from younger impacts. The moon is familiar enough to be intimate and alien enough to remain strange. It is the nearest world, and still a world. Tidal locking changes what the moon means to us. The moon keeps the same face turned toward Earth because it is tidally locked, rotating once during each orbit. The far side is not the dark side in the literal sense. It receives sunlight and darkness just as the near side does. It is far only because it faces away from us. Spacecraft revealed it to be more heavily highland, with fewer dark maria than the side visible from Earth. A simple phrase can hide a misconception. The unseen side of the moon is not a realm of permanent darkness. It is a landscape with its own sunrise and sunset. Lunar eclipses turn Earth's shadow into a visible object. A lunar eclipse happens when Earth passes between the sun and moon, and Earth's shadow falls across the lunar surface. During a total lunar eclipse, the moon often turns red or coppery. That color comes from sunlight filtered through Earth's atmosphere and bent into the shadow. The red light on the moon has passed through the rim of Earth's air, through the combined glow of sunrises and sunsets around the planet. The eclipsed moon is therefore not merely darkened. It is lit by Earth, altered by atmosphere, colored by the planet that watches it. Solar eclipses show a different kind of alignment. A total solar eclipse happens when the moon covers the sun's bright photosphere from a narrow path on Earth. The coincidence is extraordinary. The moon and sun appear nearly the same size in our sky, though the sun is vastly larger and farther away. During totality, the solar corona appears, a white outer atmosphere normally hidden by glare. The world cools, shadows sharpen, and daylight becomes briefly unfamiliar. Totality is short, often only minutes, but it can become one of the most memorable sky events in a lifetime. The naked eye planets are the wanderers of the old sky. Mercury, Venus, Mars, Jupiter, and Saturn are visible without telescopes. Ancient observers recognize them because they move against the background stars. Venus can blaze before sunrise or after sunset. Jupiter shines steadily and strongly. Mars changes brightness and color dramatically as Earth and Mars move around the sun. Saturn is dimmer, but still visible, often with a soft golden steadiness. Mercury is the most elusive, close to twilight and low near the horizon. The planets remind us that the solar system is visible from the ground. It is not only a diagram in a book. It is overhead, moving. Retrograde motion is a lesson in perspective. Retrograde motion is the apparent backward drift of a planet against the stars. It puzzled ancient astronomers because planets normally move eastward along the zodiac, then sometimes loop westward before resuming their path. The heliocentric explanation is elegant. Earth, traveling faster on an inner orbit, overtakes an outer planet such as Mars, making it appear to move backward for a while, just as a slower vehicle seems to drift backward when passed on a road. A complicated sky motion becomes simple when seen from the correct moving perspective. Venus is bright enough to feel almost still and ceremonial. Venus is often the brightest planet because it is relatively close to Earth, covered with reflective clouds, and positioned where it can shine brilliantly in twilight. It never appears far from the sun in the sky, so it becomes the morning star or evening star. Through a telescope, Venus shows phases like the moon, a crucial observation that helped support the sun-centered model of the solar system. The beautiful point of Venus hides a severe world: dense atmosphere, crushing pressure, sulfuric acid clouds, and surface temperatures hot enough to melt lead. Mars adds color and change to the planetary sky. Mars appears red because its surface dust contains iron oxides. To the naked eye, it can glow like a coal, sometimes bright and unmistakable near opposition, sometimes modest and distant. Telescopes show changing polar caps and dark markings, while spacecraft reveal volcanoes, canyons, dry riverbeds, ancient lake environments, dust storms, and minerals shaped by water. Mars is not only a red symbol in the sky, it is a geological world with a complicated past. Its changing brightness teaches orbital geometry. Its color teaches planetary chemistry. Its surface teaches the history of water and climate beyond Earth. Jupiter carries a miniature system inside its light. Jupiter is a giant world in a small system of its own. Binoculars can reveal the 4 large Galilean moons: Io, Europa, Ganymede, and Callisto. Night after night, they change position, sometimes disappearing behind Jupiter or crossing in front of it. Galileo's observation of these moons showed that not everything orbited Earth. A bright planet became evidence for a new cosmic order. Jupiter's moons are now known as worlds: volcanic Io, ocean-bearing Europa, enormous Ganymede, ancient Callisto. A point of light in the sky contains a family. Saturn hides its most famous feature from unaided eyes. Saturn is famous for its rings, though the rings are invisible to unaided eyes. Through even a small telescope, they can appear with startling clarity, a pale system of ice and dust circling the planet. The ring tilt changes over Saturn's orbit, sometimes opening wide, sometimes nearly edge-on. The rings may be temporary on cosmic timescales, bright now but not eternal. Saturn looks serene, but its ring system is dynamic. Particles orbiting, colliding, shaped by moons, gravity, and time. Meteor showers begin as sudden streaks and widen into comet history. Meteor showers occur when Earth passes through streams of debris left by comets or asteroid-like bodies. The particles are usually tiny, but they enter the atmosphere at tremendous speed, turning kinetic energy into light. The Perseids, Geminids, Leonids, and other showers return at predictable times each year. Their meteors appear to radiate from one point because of perspective, though the particles are moving on roughly parallel paths. A meteor is brief, but its history may be long. Dust shed from a comet, circling the sun, meeting Earth for one luminous second. Fireballs and meteorites make the brief streak more physical. A fireball is a meteor bright enough to stand out dramatically, sometimes casting shadows or leaving a glowing train. Most meteors burn completely in the upper atmosphere, but larger fragments can survive to reach the ground as meteorites. These stones carry records of the early solar system, sometimes older than Earth itself. A falling star, when it becomes a meteorite, is not a star at all, but ancient planetary material delivered to the surface. The sky sometimes places deep time in a field, a desert, an ice sheet, or a roof. Auroras look dreamlike, but they come from ordinary physics at the edge of space. They are made when charged particles from the sun follow Earth's magnetic field toward polar regions and collide with atoms and molecules high in the atmosphere. Oxygen often produces green light, and sometimes red. Nitrogen can contribute blue and purple. The shapes of auroras reflect magnetic fields and particle flows. Arcs, curtains, rays, folds, and pulsing forms. The northern and southern lights are space weather made visible. An aurora feels like a curtain in the sky, but it is also a sign that Earth is connected to the sun by invisible fields. Zodiacal light is one of the most delicate sights in dark sky astronomy. A faint cone or band of light seen near the ecliptic before dawn or after dusk under very dark skies. It is sunlight scattered by dust grains in the inner solar system. Those grains come from comets and asteroid collisions and are slowly lost unless replenished. The zodiacal light can be mistaken for the Milky Way, but it belongs to the solar system, not the galaxy. It is one of the gentlest sights in astronomy. Dust between planets catching sunlight after the sun itself has gone. Air glow shows that even natural darkness is not perfectly black. On the darkest natural nights, the sky still carries a faint natural glow. Air glow comes from atoms and molecules high in Earth's atmosphere emitting faint light. Long exposure photographs can reveal green or red bands invisible or subtle to the eye. Unlike auroras, air glow can cover wide areas and does not require a geomagnetic storm. It is the atmosphere shining quietly because of its own chemistry. The night is darker than day, but not empty. Even darkness has layers of light. The Pleiades gather youth, distance, and human memory into one small cluster. The Pleiades are a young, open cluster in Taurus, visible as a small group of blue-white stars. Many people see 6 or 7 with the unaided eye. Binoculars reveal many more. The cluster contains hundreds of stars born from the same molecular cloud, still traveling together before the galaxy gradually disperses them. Nearly every culture that saw the Pleiades gave them meaning, often linking them to seasons, planting, navigation, or story. They are small in the sky, but large in human memory, a cluster of young stars that became a calendar for Earth. Open clusters are loose stellar families, formed together from the same cloud. They are usually found in the galactic disk and can disperse over millions or billions of years as gravity, encounters, and galactic tides pull them apart. The sun may have been born in a cluster that has long since scattered. Somewhere in the Milky Way, there may be stars with the same birth chemistry as the Sun, now far away and anonymous. A cluster is a reminder that stars, like people, can be born together and later drift into separate stories. The Orion Nebula turns a faint patch into a birthplace. The Orion Nebula is visible to the naked eye as a faint fuzzy patch in Orion's sword. It is a stellar nursery, a region where gas and dust are forming new stars. Through binoculars, it becomes a small glow. Through telescopes and photographs, it reveals luminous gas, dark lanes, young stars, and sculpted clouds. The light has traveled for more than 1,000 years, but the process it shows belongs to the ongoing life of the galaxy. In Orion, the winter sky carries not only old stars, but the birth of new ones. Globular clusters feel still because they are so ancient. Globular clusters are ancient spherical swarms of stars orbiting the Milky Way's halo. Some contain hundreds of thousands or millions of stars and are among the oldest structures associated with the galaxy. Through binoculars, they appear as soft balls of light. Through telescopes, they begin to resolve into countless points. Their stars are old, metal-poor, and tightly bound by gravity. A globular cluster is like a memory from the young universe, still shining after most of cosmic history has passed. Sirius is familiar brightness with hidden depth. Sirius is the brightest star in the night sky because it is both nearby and intrinsically luminous. It lies about 8.6 light-years away and has a white dwarf companion, Sirius B. That companion is roughly Earth-sized, but contains a mass comparable to the Sun, the remnant core of a star that once evolved beyond its main life. Ancient observers saw a brilliant point. Modern astronomy reveals a system with a living star and a stellar remnant. Sirius shows how the sky can be familiar to the eye and surprising to the mind. Betelgeuse gives Orion a red and unstable heart. Betelgeuse is a red supergiant in Orion, enormous, cool on its surface compared with the Sun, and near the end of its life. Its brightness varies, and its dramatic dimming in 2019 and 2020 drew worldwide attention. The event was not the beginning of a supernova, but a combination of surface changes and dust. Betelgeuse will explode someday, yet astronomically soon can still mean thousands or tens of thousands of years. The red star in Orion is a reminder that stars are not permanent decorations. They are lives in progress. Supernovae bring stellar death into the larger story of renewal. A supernova is the explosive death of certain stars, releasing enormous energy and scattering elements into space. Massive stars can collapse, leaving neutron stars or black holes. White dwarfs in some binary systems can also explode under particular conditions. Supernovae are destructive nearby, but they enrich galaxies with heavy elements. The calcium in bones and the iron in blood belong to a universe where stars die. The night sky's beauty is gentle to the eye, but its history includes fire, collapse, and renewal. Star color is one of the easiest clues to physics because it reveals surface temperature. Blue-white stars are hotter, red and orange stars are cooler at their surfaces. This reverses everyday associations of blue with cold and red with warmth, because in physics blue light carries more energy than red light. Vega, Rigel, Sirius, Betelgeuse, Aldebaran, and Antares all show subtle differences that become easier to notice with patience. At first, stars may seem simply white. After time under the sky, the eye begins to find gold, ice blue, amber, and deep red. Binary stars remind us that a single point may be a relationship. Many stars belong to binary or multiple systems. Two stars may orbit one another over hours, years, or centuries. Some are wide pairs. Some are close enough to exchange material. Eclipsing binaries dim regularly when one star passes in front of another from Earth's viewpoint. Algol and Perseus is a famous example. Its repeating brightness changes once giving it an eerie reputation. A single point of light may hide two stars in gravitational conversation. The sky often grows more complex when examined closely. Variable stars make time visible in starlight because they change brightness for many reasons. Some pulsate, some eclipse, some flare, some erupt. Cepheid variables are especially important because their pulsation periods reveal their intrinsic luminosities, allowing astronomers to measure distances. Henrietta Swan Leavitt's discovery of this relationship helped open the scale of the universe. A star that brightens and fades can become a ruler for measuring galaxies. The changing star teaches distance. The pulse becomes a ladder rung across space. Andromeda is distance made visible to the unaided eye. The Andromeda galaxy is visible under dark skies as a faint oval smudge. Its light has traveled about 2.5 million years. It left before modern humans existed, crossed intergalactic space through the entire span of human evolution, and arrives now as a soft patch near the limit of unaided vision. The full galaxy is much wider in the sky than most people realize, but only its brighter central region is easy to see. Andromeda is not an image of distance. It is distance itself, arriving quietly as light. The future merger of Andromeda and the Milky Way sounds violent, but unfolds slowly. Andromeda and the Milky Way are moving toward an eventual merger several billion years from now. The word collision is dramatic, but stars are so widely spaced that direct star-to-star impacts will be rare. Gravity will reshape both galaxies, stir gas, and build a new structure over immense time. The night sky of that distant future would be transformed, though the Sun and Earth will also be deep into their own evolution by then. Galaxies live on timescales so large that even their encounters unfold like slow weather. The Magellanic Clouds give the southern sky visible companion galaxies. The large and small Magellanic Clouds are satellite galaxies of the Milky Way, visible from southern latitudes as detached cloudy patches. They were known to southern observers long before European navigators recorded them. The Large Magellanic Cloud contains the Tarantula Nebula, one of the most active star-forming regions nearby, and hosted supernova 1987A, the nearest naked-eye supernova of modern times. For the southern sky, galaxies are not only distant telescopic objects. Some are visible companions to the Milky Way itself. The Southern Cross is small in area and large in cultural meaning. The Southern Cross, or Crux, is the smallest official constellation by area, but one of the most famous in the Southern Hemisphere. It helps indicate the direction of the South Celestial Pole, though less directly than Polaris indicates north. It appears in flags and navigation traditions and sits near the dark coal sack. The bright pointer stars Alpha and Beta Centauri nearby help locate it. The Southern Cross shows how a small pattern of stars can become a cultural anchor for half the world. Alpha Centauri brings interstellar distance close enough to name. Alpha Centauri is the nearest star system to the Sun, a triple system about 4.37 light-years away. The two main stars are roughly Sun-like, while Proxima Centauri is a faint red dwarf and the nearest individual star. Proxima has known planets, including one that lies in a region where temperatures could allow liquid water under the right conditions. But habitability is uncertain, especially around active red dwarf stars. The nearest stars are close only in cosmic language. Their light still takes years to cross the gap. Exoplanets have changed what every star can mean. Thousands of exoplanets have now been confirmed around other stars, and the number continues to grow. Some are gas giants close to their stars. Some are rocky worlds. Some orbit red dwarfs. Some circle multiple stars. Some systems are compact and strange compared with our solar system. The discovery of exoplanets changed the emotional meaning of the night sky. Stars are not only stars. Many are suns with worlds. Looking up now means looking at possible solar systems, each hidden inside a point of light. Habitability is a careful possibility, not a promise. The habitable zone is the range around a star where liquid water could exist on a planet's surface, assuming suitable atmospheric pressure and chemistry. It is useful, but it is not a promise. A planet in that zone can still be hostile, airless, tidally locked, frozen, scorched, or stripped by stellar activity. Habitability depends on atmosphere, geology, magnetic environment, chemistry, time, and chance. The search for life is not the search for a label. It is the search for a stable world where conditions allow complexity to persist. Hubble changed the meaning of an empty patch of sky. The Hubble Space Telescope changed astronomy by observing above most of Earth's blurring atmosphere. Its deep field images pointed at apparently empty regions and revealed thousands of galaxies. The lesson was simple and vast. Darkness can be full of things too faint for ordinary sight. The Hubble Ultra Deep Field showed that a tiny patch of sky could contain a history of galaxies stretching across billions of years. A blank place in the sky became crowded when the exposure was long enough. Emptiness was partly a failure of patience and sensitivity. Webb extends that patience into infrared light. The James Webb Space Telescope observes primarily in infrared light, making it powerful for studying early galaxies, star-forming regions hidden by dust, and exoplanet atmospheres. Because cosmic expansion stretches the light from the earliest galaxies toward infrared wavelengths, Webb can see deeper into cosmic dawn than earlier observatories. It has confirmed galaxies from only a few 100 million years after the Big Bang, and the record continues to be refined. The deep universe is not static in human knowledge. New instruments keep moving the horizon backward in time. The cosmic microwave background is the oldest light available to instruments. It was released when the universe was about 380,000 years old and became transparent. Expansion has stretched that light into microwaves, giving it a temperature of about 2.7 Kelvin today. Tiny variations in it carry information about the early density patterns that later grew into galaxies and clusters. The night sky seen by eyes is young compared with this background. Behind the stars is an afterglow from the early universe. The observable universe stretches the imagination beyond the age of its light. It is about 13.8 billion years old, but its observable radius is much larger than 13.8 billion light years because space expanded while light traveled. The most distant observable regions are now roughly 46 billion light years away in present-day distance. This does not mean objects moved locally through space faster than light. It means space itself expanded. The scale is difficult to imagine, but the idea is clear enough. The universe is bigger than the time light has traveled might first suggest. Gravitational lensing makes gravity visible through distortion. Gravitational lensing occurs when mass bends the path of light, as described by general relativity. A galaxy or cluster can act like a lens, distorting, magnifying, or multiplying the image of a more distant object behind it. Lensing lets astronomers study galaxies that would otherwise be too faint and also map mass, including dark matter, through its gravitational effect. Light does not always travel through the universe as a simple straight messenger. Space itself can curve its path. Pulsars make dead stars into clocks. Pulsars are rotating neutron stars whose beams sweep across Earth like lighthouse signals. Their pulses can be extraordinarily regular, especially in millisecond pulsars. The first pulsar was discovered by Jocelyn Bell Burnell in 1967 as a repeated radio signal, so precise it briefly invited playful speculation. The real explanation was more astonishing: a collapsed stellar core spinning rapidly and sending beams through space. A dead star can become one of the most precise clocks in the universe. Black holes place darkness inside gravity, regions where gravity is so intense that beyond the event horizon, light cannot escape. They are invisible directly, but their surroundings can shine when gas heats as it falls inward. Stars orbiting unseen masses reveal black holes. Gravitational waves reveal mergers. At the center of the Milky Way lies Sagittarius A star, a supermassive black hole about 4 million times the mass of the Sun. The night sky contains not only lights, but places defined by the absence of escaping light. Dark matter shapes the visible universe without joining its light. Dark matter does not shine, absorb, or reflect light in ordinary ways, but its gravity shapes galaxies and clusters. Galaxy rotation, cluster dynamics, and gravitational lensing all point to more mass than visible matter can explain. The nature of dark matter remains unknown, but its effects are woven through cosmic structure. The Milky Way itself sits in a much larger dark matter halo. The visible sky is therefore not the whole mass of the universe. Much of what shapes the lights is itself dark. Dark energy is the name given to an even deeper uncertainty, the apparent cause of the accelerated expansion of the universe. Distant supernovae and other observations show that cosmic expansion is not merely continuing, but speeding up. The explanation remains one of the great open questions of physics. It is not visible in a telescope as an object, but inferred from the large-scale behavior of space. The night sky is filled with stars, yet its deepest mystery may be the expansion of the darkness between galaxies. Spectroscopy turns starlight into evidence. Spectroscopy spreads light into its component colors and reveals dark or bright lines produced by atoms and molecules. From those lines, astronomers learn what stars are made of, how hot they are, how fast they move, whether they rotate, and whether they are surrounded by gas. A star is too far to touch, but its light arrives carrying a chemical signature. Every starbeam is a message. Spectroscopy is the art of learning to read it. Redshift makes expansion readable in color. It occurs when light is stretched toward longer wavelengths. It can be caused by motion away from the observer, by gravity, or by the expansion of the universe. The redshift of distant galaxies reveals cosmic expansion and allows astronomers to estimate how far back in time their light was emitted. The farther galaxies generally show larger cosmological redshifts. The universe does not only shine, it stretches the light it sends. Parallax gives nearby stars a direct distance. It is the apparent shift of a nearby object against a distant background when viewed from different positions. Nearby stars shift slightly as Earth moves around the Sun. The shifts are tiny, but they provide direct distance measurements. The unit parsec comes from this method, the distance at which a star would show a parallax of 1 arcsecond. A small apparent wobble in a star's position becomes a ruler stretching across interstellar space. Gaia has turned the Milky Way into a moving map by measuring positions and motions for more than 1 billion stars, creating an extraordinarily detailed map of the Milky Way. It tracks not only where stars are, but how they move. From this, astronomers reconstruct stellar streams, galaxy structure, clusters, and the history of past mergers. The sky that looks fixed becomes a moving ocean of stars. The Milky Way is not a still photograph. It is a dynamic system, and Gaia has helped reveal its motion. Star formation often begins in darkness, inside cold molecular clouds where regions collapse under gravity. Dust hides many young stars from visible light, but infrared and radio observations can see through or around that darkness. Protostars grow, disks form around them, jets may shoot outward, and planets may begin assembling from dust and gas. The process is messy, beautiful, and fundamental to everything that later becomes a solar system. A star can be born inside a darkness so thick that visible light cannot escape. Night sometimes hides beginnings. Planet formation turns dust into worlds. They grow from disks around young stars. Dust grains collide and stick, forming larger bodies, then planetesimals, then planetary embryos. Gravity, impacts, migration, and resonance shape the final system. Our own moon may have formed from debris after a giant impact early in Earth's history. The calm sky contains worlds that were built through collisions and rearrangement. The serenity of a planet in the night sky often conceals a violent childhood. Cosmic elements connect the sky with the body. Some hydrogen and helium were forged in the early universe, while heavier elements were made in stars, supernovae, stellar winds, and neutron star mergers. Carbon, oxygen, nitrogen, iron, calcium, and many other elements in living bodies have cosmic histories. The stars are not separate from life. They are part of the ancestry of matter. Looking up is not looking away from the body. It is looking toward the processes that helped make bodies possible. Seasonal skies make the year visible overhead. The night sky changes with the seasons because Earth orbits the sun. In northern winter, Orion and bright winter stars dominate. In northern summer, the night side of Earth faces richer regions of the Milky Way towards Sagittarius and Scorpius. Spring and autumn often open views out of the galactic plane toward distant galaxies. The same principle applies differently across hemispheres and latitudes. A year is not only weather and daylight. It is also the slow rotation of celestial scenery. Navigation turns stars into direction. Stars have guided navigation for thousands of years. Polaris helps in the northern hemisphere, while the Southern Cross helps point toward the south celestial pole. Sailors used rising and setting points, star altitudes, and seasonal knowledge. Polynesian navigators crossed vast ocean distances using stars, swells, winds, birds, and clouds. The sky was a map, but also a memory system carried in trained minds. To navigate by stars is to turn the night into direction. Calendars began as repeated sky events made useful. The sky gave early human beings reliable cycles. The day, the lunar month, the solar year, the seasons, and the return of particular stars before dawn. The heliacal rising of Sirius mattered in ancient Egypt. The Pleiades marked seasons in many cultures. Solstices and equinoxes helped structure ritual and agriculture. A calendar is a human response to repeated sky events. Timekeeping began not only in machines, but in watching light return to the same places. Binoculars offer a gentle bridge between eyes and telescopes. Binoculars can reveal more of the night sky than many people expect. They show the moon's craters, Jupiter's moons, the Pleiades as a cluster, the Andromeda galaxy more clearly, bright star fields, and some nebulae in clusters. They keep a wide field of view and use both eyes, preserving a sense of natural looking. For many beginners, binoculars are the gentlest instrument. A telescope narrows and magnifies. Binoculars invite the sky closer without taking away its spaciousness. Small telescopes teach realistic wonder. Small telescopes can reveal Saturn's rings, Jupiter's cloud bands, lunar mountains, double stars, and bright deep sky objects. But visual observing is not the same as astrophotography. Many galaxies are faint gray smudges. Nebulae may not show the vivid colors seen in long exposure images. The eye gathers light moment by moment, while cameras can collect it for minutes or hours. The telescope teaches subtlety. It asks the observer to appreciate faintness as a form of truth. Astrophotography is a translation of faint light into accumulated vision. Astronomical images often combine long exposures and filters. Colors may represent wavelengths beyond ordinary human vision or be enhanced to reveal structure. This does not make the images false. They are translations of data into visible form. A nebula photograph is both scientific record and visual art. It shows what the eye cannot gather in real time. The camera has become another kind of eye, patient enough to let faint light accumulate. Satellites have added human motion to the night. Satellites are now part of the modern night sky. Some appear as steady moving points, shining by reflected sunlight. The International Space Station can be brighter than many stars, gliding silently across the sky. Large satellite constellations have raised concern because they can affect astronomical observations and change the natural appearance of the night. Human technology has entered the sky visibly. The night above Earth is no longer untouched. It has become an environment that also requires stewardship. Space debris reminds us that orbit is now an environment we affect. Thousands of objects orbit Earth: working satellites, old rocket bodies, fragments from collisions, and smaller debris. Most are invisible from the ground, but they matter for spacecraft and future access to orbit. At orbital speeds, even small objects can be dangerous. The space just beyond the atmosphere is not empty of human consequence. Astronomy now includes responsibility for the region between Earth and the wider universe. Comets bring cold outer reservoirs into temporary visibility. Comets are icy bodies that brighten as they approach the sun, releasing gas and dust into tails. The dust tail follows the comet's orbit more broadly, while the ion tail points away from the sun, shaped by the solar wind. Ancient people often feared comets because they appeared suddenly and broke the regularity of the heavens. Modern science sees them as preserved material from the solar system's early history. A comet is a visitor from cold distances, briefly warmed into visibility. Halley's Comet links astronomy with generations, returning roughly every 76 years. It appeared in 1066 and was recorded in the Bayeux Tapestry. It returned in 1986 and will return again in 2061. A periodic comet is a clock made of ice and dust, too slow for one life to own completely, but fast enough for human history to remember. Some sky events connect grandparents, children, and people not yet born. Olber's paradox turns the darkness itself into evidence. The darkness of the night sky is itself scientific evidence. If the universe were infinite, eternal, static, and filled evenly with stars, every line of sight might eventually end on a stellar surface, and the night sky would be bright. It is not. Modern cosmology explains the darkness through the finite age of stars, cosmic expansion, and the evolution of the universe. Darkness is not nothing. It carries information. The black space between stars helps tell us what kind of universe we live in. The atmosphere is both veil and protector, helping and hindering astronomy at the same time. It makes stars twinkle, scatters city light, blurs telescopes, and blocks some wavelengths. But it also protects life, gives breath, burns up meteors, creates auroras, colors eclipses, and makes the sky blue by day. Every ground-based view of space passes through the very shield that allows observers to exist. We do not look at the universe from outside Earth. We look through Earth's living envelope. From orbit, the night sky and Earth exchange roles. Above most of the atmosphere, stars do not twinkle. Earth becomes the bright object, blue, white, brown, green, and glowing at the edge. The night side shows lightning, auroras, fires, and city lights. Looking outward reveals space. Looking back reveals home. The same sky that makes Earth seem small also makes Earth seem precious. Astronomy has always turned the gaze upward, but spaceflight turned it back toward the planet. The celestial sphere is imaginary, but useful, an apparent dome on which stars seem to lie. It is not physically real, because stars are at different distances, but it remains extremely useful for mapping. Coordinates such as right ascension and declination give addresses on this apparent sphere. The eye experiences the sky as direction first and depth later. Astronomy begins with a dome of lights and gradually unfolds that dome into space. Star names carry language through the sky. Many bright star names carry histories of language: Arabic, Greek, Latin, and other traditions preserved through astronomy. Deneb, Altair, Aldebaran, Betelgeuse, Rigel, Vega, and many others are not only labels. They are traces of human transmission. Catalog numbers add another layer, giving stars precise scientific identities. A star can be myth, navigation point, spectrum, coordinate, distance, and physical object all at once. The named sky is a meeting place between culture and measurement. The Fermi question gives silence another meaning. The vast number of stars and planets raises the question of whether life or intelligence exists elsewhere. The Fermi paradox asks why, if the galaxy is old and potentially full of worlds, we have not found clear evidence of other technological civilizations. There are many possible answers and no final one. Life may be rare, intelligence may be rare, civilizations may be brief, distances may be too great, or we may not yet know how to look. The silence of the sky is not proof of emptiness. It is a question still open. Every observing night has its own local character. Every observing night has its own conditions. Cold air may be clear but uncomfortable. Summer nights may be warm but hazy. High altitude can reduce atmospheric thickness. Dry deserts can reveal spectacular contrast. Coastal air can soften horizons. A forest clearing frames a portion of the sky, while an open plain gives the dome in full. The universe is the same, but the local experience changes. Stargazing is cosmic and earthly at once. The ground, weather, and body are always part of the observation. Latitude gives every place its own sky. The sky changes with latitude. Near the equator, many northern and southern constellations become visible over the year. Near the poles, stars circle the horizon and long seasons of darkness or daylight dominate. Some stars never set from a given place, others never rise. Every location on Earth has a particular sky, shaped by geometry. To travel north or south is to change the universe overhead, even though the universe itself has not changed. Earth's motion hides beneath the feeling of rest. A person lying still under the stars is not motionless. Earth rotates, carrying the observer eastward. Earth orbits the sun. The sun orbits the Milky Way. The Milky Way moves within the local group. Stillness is local and relative. The body rests, but the planet moves continuously through space. This is one of the quietest paradoxes of the night sky. Peace in the experience, motion in the reality. Scale gives the sky its quiet emotional force. Astronomy changes the scale of ordinary thought. Human concerns do not become meaningless, but they become placed inside a wider frame. A worry that filled the day may feel different under light that has traveled for centuries. The sky does not solve life, but it can loosen the grip of immediacy. It reminds the mind that time is larger than one moment. There is comfort in not being the largest thing in the picture. The sky is shared across human lives. Every human life has unfolded under the same moon and the same turning earth. The stars have crossed above deserts, cities, forests, oceans, farms, ships, temples, hospitals, and quiet rooms. Cultures have named them differently, measured them differently, feared them, loved them, and used them. The sky is a shared inheritance, even when access to its darkness is unequal. To look up is to join a very old human gesture. Learning the sky can begin with one object. Find the moon. Find Venus. Find Orion. Find the Big Dipper. Find the Southern Cross. Find the Summer Triangle. Once one pattern is known, it becomes an anchor for the next. Slowly, the sky changes from scattered lights into a familiar landscape. Recognition creates intimacy without reducing mystery. The universe remains vast, but a small part of it becomes home. Patience is one of the quiet skills the night sky teaches. The night sky rewards patience more than speed. At first, there may be only a few bright points. Then faint stars appear. A satellite crosses. A meteor flashes. The Milky Way gains texture. A planet rises above a roof. A constellation that was low becomes clear. The longer one looks, the more the sky gives. This is why the sky belongs naturally to rest. It cannot be rushed into revealing everything at once. There is another quiet wonder in the way star color becomes temperature. To the unaided eye, most stars appear simply white, because the eye is not very sensitive to color in dim light. But the brighter ones show hints. Betelgeuse is warm orange-red. Rigel is blue-white. Antares is reddish. Sirius can flash blue, white, and red when it is low in the turbulent atmosphere, though its true color is white. Color is not decoration. It is information. A blue star is generally hotter at its surface than a yellow star. A red star is generally cooler at its surface. A glance becomes a thermometer when the physics is understood. The human eye does not separate starlight into a spectrum, but every star carries one. When astronomers spread starlight through a prism or diffraction grating, the light becomes a band of colors crossed by dark absorption lines or bright emission lines. Those lines are fingerprints of atoms and molecules. Hydrogen, helium, calcium, sodium, oxygen, iron, and many other elements leave patterns in light. Through spectra, astronomers learn that stars are not made of some separate heavenly substance. They are made from the same elements that make planets, rocks, oceans, bodies, and breath. This was one of the great quiet revolutions of astronomy. Before spectroscopy, a star was a point of light with position and brightness. After spectroscopy, it became a physical object with temperature, composition, motion, magnetic activity, and evolutionary state. The same light that comforts the eye can also reveal chemistry across light years. Nothing has to be touched. A star sends its own evidence through space, and a small instrument on Earth can read it. The Doppler effect adds motion to that evidence. If a star is moving toward us, its spectral lines shift slightly toward shorter, bluer wavelengths. If it is moving away, they shift toward longer, redder wavelengths. These shifts can be tiny, but they are measurable. They reveal whether stars approach or recede, whether galaxies rush away in the expanding universe, whether a star is pulled by an unseen planet, whether two stars orbit each other too closely for telescopes to separate. Light becomes a messenger of motion. This is how exoplanets were first found around sun like stars. A planet does not simply orbit a star while the star remains perfectly still. Both orbit their shared center of mass. The star wobbles slightly, pulled by the planet's gravity. That wobble shifts the star's spectral lines back and forth. Later, many planets were found by transits, when a planet passes in front of its star and blocks a tiny fraction of light. A dip in brightness, repeated at regular intervals, can reveal a world. There is something deeply gentle about that method. A planet may be invisible directly, lost in the glare of its star, but its shadow is enough. A world announces itself by making starlight briefly less bright. Some of these planets are giant worlds close to their stars. Some are rocky. Some orbit red dwarfs. Some belong to systems packed with several worlds. Some may have atmospheres. Some may have clouds, winds, oceans, or surfaces that no eye has ever seen. The number of confirmed exoplanets has grown from none around sun like stars within living memory to thousands. This changes the emotional meaning of the night sky. The stars are not only distant suns. Many are centers of systems. A point of light may have planets around it, moons around those planets, storms, rings, ice, rock, chemistry, perhaps even conditions where life could begin. The sky becomes less like a ceiling of lamps and more like a forest of possible homes. Habitability is a careful word. A planet in the habitable zone is not automatically alive and not automatically comfortable. It means only that the planet receives an amount of stellar energy that could allow liquid water on a suitable surface under suitable atmospheric conditions. A planet may be too dry, too irradiated, tidally locked, stripped of atmosphere, covered in ice, or transformed by greenhouse gases. The habitable zone is a beginning of a question, not the answer. Red dwarf stars complicate the question. They are small, cool, long-lived, and extremely common. Their habitable zones lie close to the star, so planets may orbit quickly and may become tidally locked, with one side facing the star for long periods. Many red dwarfs produce flares, especially when young, sending ultraviolet and X-ray radiation into nearby planetary environments. Yet their long lifetimes mean stable conditions could persist for enormous spans of time if atmospheres survive. Around such stars, life, if it exists, would have to belong to a different kind of daylight. The night sky therefore contains many kinds of suns. Our sun is not the smallest, largest, hottest, coolest, youngest, or oldest kind of star. It is a middle-aged yellow dwarf, ordinary in many ways and precious to us because of the one planet where we know life exists. Massive blue stars burn quickly and die young. Small red dwarfs can last for trillions of years, far longer than the present age of the universe. Red giants swell near the ends of their lives. White dwarfs cool slowly as stellar embers. Neutron stars compress mass into unimaginable density. A star's life is governed mostly by mass. Mass determines how strongly gravity squeezes the core, how hot the core becomes, how quickly nuclear fuel is consumed, and what happens when the fuel changes. Low-mass stars live slowly. High-mass stars live brilliantly and briefly. The most massive stars can end as supernovae, scattering heavy elements into space. Those elements may later become new stars, planets, and bodies. In this way, the night sky is not only a display of objects, it is a history of recycling. The calcium in bones, the iron in blood, the oxygen in water, and the carbon in living tissue were forged through cosmic processes. Some elements were made in stars, some in supernovae, some in neutron star mergers, some in the first minutes after the Big Bang. A person looking at the stars is made of earlier generations of stars. The separation between observer and sky is real in distance, but not in ancestry. The body is local matter with cosmic history. Nebulae are places where this history becomes visible. Some nebulae are stellar nurseries, cold clouds where gas and dust collapse into new stars. Some are glowing regions of hydrogen lit by hot young stars. Some are planetary nebulae, shells of gas shed by dying sun like stars. Some are supernova remnants, expanding debris from catastrophic stellar deaths. A small telescope can show a few of these as pale mist. Photographs reveal colors, filaments, cavities, and shock fronts. But even the unaided eye can see the Orion Nebula as a faint haze, a nursery suspended in winter. The Orion Nebula is especially powerful because it is both ancient to human vision and young in stellar terms. The light has traveled more than 1,000 years to reach Earth, yet the stars being born there are infants by astronomical standards. In the same constellation where ancient cultures saw hunters, gods, animals, or seasonal signs, modern astronomy sees collapsing clouds and newly formed stars. Myth and physics overlap on the same patch of sky. The Pleiades offer another kind of youth. Their blue stars are bright, hot, and relatively young. Dust near the cluster reflects their light, creating a faint blue nebulosity in long exposures. Many cultures have watched the Pleiades rise and used them to mark seasons of planting, navigation, ceremony, or storytelling. A cluster is a family of stars born together, slowly drifting apart under the influence of gravity and galactic tides. What looks like a small sparkle is a young stellar association traveling through the Milky Way. Globular clusters, by contrast, are old. They belong to the halo of the galaxy, dense swarms of ancient stars orbiting outside the bright disk. Through binoculars, some appear as soft round patches. Through telescopes, they break into countless points. Their stars are among the oldest in the Milky Way. Looking at a globular cluster is like looking at a fossil population, not dead, but ancient, formed when the galaxy was young and the universe itself had not yet built its later richness. The Milky Way contains both youth and age. In the disk, gas clouds form new stars. In the halo, old stars continue their long orbits. In the center, a supermassive black hole sits in Sagittarius A star, surrounded by stars moving at extraordinary speeds. The galaxy has spiral arms, dust lanes, stellar streams, satellite galaxies, and traces of past mergers. The band visible from Earth is only the edge on glow of a structure too large to see from outside. We live inside the thing we are trying to understand. This makes galactic astronomy feel like trying to map a forest while standing among the trees. The Milky Way surrounds us, so its shape had to be inferred from star counts, gas motions, distances, radio maps, infrared surveys, and the motion of objects around the center. Dust blocks visible light in many directions, especially toward the galactic center, but infrared and radio waves can pass through more easily. Different wavelengths reveal different parts of the same home. Radio astronomy opened an invisible sky. The human eye sees only a narrow band of electromagnetic radiation, but the universe emits radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. At radio wavelengths, cold hydrogen gas can be mapped. Pulsars tick. Molecules in space reveal themselves. The cosmic microwave background fills the sky. The visible night sky is only one chapter in a much larger spectrum. Infrared astronomy reveals cool objects and hidden regions. Dust that blocks visible light can glow in infrared. Star-forming clouds become more transparent. Brown dwarfs, cool stars, planetary disks, and distant galaxies become easier to study. Webb's power comes partly from this infrared vision. It looks through dust and back into early cosmic time, where the expansion of the universe has stretched ancient light into wavelengths longer than human eyes can receive. Ultraviolet astronomy shows hot stars, energetic gas, and young stellar populations, but much ultraviolet light is absorbed by Earth's atmosphere. X-ray astronomy reveals violent regions. Black holes pulling in matter, neutron stars, supernova remnants, hot gas in galaxy clusters. Gamma-ray astronomy traces the most energetic events. Every wavelength changes the universe that appears. The same sky becomes many skies depending on the instrument. Even gravity now has a kind of astronomy. Gravitational waves are ripples in space-time produced by accelerating massive objects, such as merging black holes or neutron stars. They do not arrive as light, and the human eye will never see them, but instruments can detect their passing as tiny changes in length. When gravitational waves from merging neutron stars are combined with light from the same event, astronomy becomes multi-messenger. Gravity, light, particles, and sometimes neutrinos all telling parts of the same story. Neutrinos are another quiet messenger. They are extremely light, nearly ghost-like particles that pass through matter with little interaction. The Sun sends enormous numbers of neutrinos through Earth every second. A supernova can release a flood of them. Detecting neutrinos requires vast detectors deep underground, under ice, or underwater, shielded from ordinary noise. The night sky above may look still, but invisible particles and waves are constantly crossing the planet. This should make the simple act of looking up feel even more profound, not less. The eye sees only a little, but that little is real. It is the visible surface of a universe that continues beyond sight in every direction and every wavelength. A star seen by eye, a galaxy photographed by telescope, a gravitational wave measured by interferometers, and a neutrino caught in deep ice are different ways the same universe becomes knowable. The moon remains the nearest place where the sky becomes landscape. With binoculars, craters and mountains appear. The line between lunar day and night, called the terminator, throws long shadows that make relief visible. The moon is not smooth. It is battered, layered, and ancient. Its face records impacts from a time when the solar system was more crowded with debris. Each crater is a frozen memory of collision. Earthshine is one of the gentlest lunar sights. When the moon is a thin crescent, the dark part of its face can glow faintly. That glow is sunlight reflected from Earth onto the moon and back again. To see Earthshine is to see the Earth lighting the moon. The planet becomes the lamp. From the moon, at that moment, Earth would appear bright in the lunar sky, clouded, blue, and alive. Libration adds another subtlety. The moon is tidally locked, so the same side generally faces Earth, but slight rocking motions allow us over time to see a bit more than half of its surface. Not all at once, and not dramatically, but gradually. The moon keeps one face toward us, yet not perfectly. Even familiar things have margins we only glimpse with patience. Tides link the moon to the oceans. The moon's gravity pulls on Earth, raising tidal bulges in water and, more subtly, in the solid Earth itself. The sun also contributes. The result is a rhythm of rising and falling seas, spring tides near new and full moon, neap tides near quarter phases, local complexities shaped by coastlines and ocean basins. The moon is not only a light in the sky, it is a force moving water. The moon is also slowly moving away from Earth, at a few centimeters per year, measured by laser ranging to reflectors left by Apollo astronauts and other missions. In the deep past, the moon was closer and tides were stronger. In the far future, the moon will appear smaller in the sky. Total solar eclipses, possible now because the moon and sun appear nearly the same size, are a temporary gift of orbital geometry. The coincidence will not last forever. The sun, though absent from the night sky in the ordinary sense, shapes many night phenomena. It lights the moon and planets. It creates twilight. It drives auroras through solar wind. It releases particles that interact with Earth's magnetic field. It determines the seasons through Earth's tilt and orbit. Even in darkness, the sun remains present as cause. Night is not the absence of solar influence. It is the shadowed side of a planet still held in sunlight's system. Twilight itself has stages. Civil twilight leaves enough light for many activities. Nautical twilight darkens the horizon but still allows sailors to see both sea and stars for navigation. Astronomical twilight ends when the sun is far enough below the horizon that the sky becomes as dark as it will become, apart from moon, air glow, zodiacal light, and human light. Darkness is not an instant switch. It is a descent through layers. Air glow is one of the faintest natural lights of the night. Even on moonless nights far from cities, the sky is not perfectly black. Molecules and atoms high in the atmosphere emit faint light from chemical and physical processes, creating a subtle glow. Long exposure photographs reveal it as green or red bands. To the naked eye, it usually contributes only to the fact that the natural night sky has a floor of brightness. Space looks black, but Earth's atmosphere glows softly. Noctilucent clouds add another rare layer. They form high in the mesosphere, far above ordinary weather clouds, and can shine after sunset or before sunrise when sunlight still reaches them while the lower atmosphere is dark. They appear as delicate blue-white ripples, often at high latitudes in summer. They are made of tiny ice crystals around dust particles. They remind us that the upper atmosphere has its own weather, faint and high enough to seem almost celestial. Satellites have changed the night sky in a new way. Now, a bright point moving steadily across the stars may be a satellite reflecting sunlight. The International Space Station can appear brighter than any star, gliding silently for a few minutes before fading into Earth's shadow. Satellite constellations now create strings and trails that can surprise observers and challenge astronomical imaging. The modern sky contains human-made wanderers as well as natural ones. This is not only an aesthetic issue. Astronomers worry about satellite brightness, radio interference, and the loss of an undisturbed sky. The sky has always changed through natural motion, but now human technology writes moving marks across it. The challenge is to balance communication, navigation, and technology with the scientific and cultural value of darkness. A quiet sky is not empty space above unused land. It is part of human heritage and scientific infrastructure. Light pollution is often treated as less serious than other forms of pollution because it seems intangible. But artificial light at night alters ecosystems. It can disorient migrating birds, affect insects, change predator-prey relationships, disrupt amphibian behavior, influence plant rhythms, and interfere with human sleep. It also erases the Milky Way for many people. A child raised under bright urban sky may grow up without ever seeing the galaxy that contains the sun. The solution does not require eliminating all-night lighting. It requires better lighting, shielded fixtures, warmer colors, lower intensity, motion sensors, curfews where appropriate, and light directed where needed rather than sprayed upward. A safer street and a darker sky can coexist if design is thoughtful. Darkness is not the enemy of safety. Wasteful glare often harms visibility while brightening the sky. Good light respects both human needs and nocturnal life. Calendars are another ancient gift of the night sky. The moon gives months. The sun gives years and seasons. The stars give sidereal patterns that return with the same time of year. The heliacal rising of certain stars, the first dawn appearance after a period of invisibility, helped ancient cultures mark seasonal events. Astronomy began not as abstraction, but as timekeeping tied to crops, rivers, migrations, ceremonies, and survival. Navigation grew from the same attention. Polaris in the north, the Southern Cross in the south, rising and setting points, star paths, ocean swells, winds, birds, and clouds all became tools for people crossing land and sea. Polynesian navigators used stars as part of a wider environmental knowledge system, reading the ocean and sky together. Navigation by sky is not merely looking at a star. It is integrating patterns over time while moving through the world. The night sky also measures Earth's own shape and motion. The change of visible constellations with latitude, the shifting height of Polaris above the northern horizon, the curved shadow of Earth on the moon during a lunar eclipse, the timing of eclipses, and the apparent motion of planets all contributed to the development of astronomy as a precise science. The sky was the first laboratory, enormous, regular, public, and patient. There is beauty in the fact that ancient instruments could be simple. A stick casting a shadow can measure solar height. A line of stones can mark a solstice sunrise. A sighting tube can align with a star. A water clock can track hours. Careful records can reveal cycles too slow for one night. Precision began with attention long before electronics. The universe offered patterns, and human beings learned to keep them. Modern astronomy has instruments of almost unimaginable power, but the emotional beginning remains unchanged. A person looks up and notices. This noticing can lead to equations, telescopes, satellites, detectors, and space missions. But the first motion is still a quiet turning of the head. The night sky remains one of the few sciences whose subject can be seen directly before it is studied formally. The distance ladder shows how carefully that direct seeing becomes measurement. Nearby stars can have distances measured by parallax, the tiny apparent shift caused by Earth's orbit around the Sun farther away. Cepheid variables reveal distance through their period luminosity relationship. Farther still, certain supernovae provide standardizable candles. Redshift reveals cosmic expansion. Each rung depends on the one below it. The scale of the universe was not guessed in one leap. It was climbed. Henrietta Swan Leavitt's work on Cepheid variables was one of the essential rungs. By studying variable stars in the Magellanic Clouds, she found that their pulsation periods related to their intrinsic brightness. This relationship allowed astronomers to measure distances beyond the reach of parallax. It helped transform fuzzy nebulae into galaxies beyond the Milky Way. A quiet pattern in variable starlight opened the modern universe. Edwin Hubble used such distance methods to show that Andromeda was not a nearby cloud inside the Milky Way, but another galaxy far beyond it. Later, observations of galaxy redshifts helped establish that the universe is expanding. The night sky changed from a static backdrop into an evolving cosmos. Space itself became dynamic. Distance and time became linked. Looking farther meant looking earlier. The cosmic microwave background is one of the most profound examples of looking earlier. It cannot be seen with eyes, but it fills the universe as ancient radiation from when the cosmos became transparent. It is not a wall in space, but a surface in time, the oldest light we can observe directly. Tiny variations in that background became the seeds from which galaxies and clusters grew. The smoothness and slight unevenness together tell the story of a universe that was once hot, dense, and nearly uniform. Dark matter entered astronomy through gravity. Stars and galaxies moved in ways that visible matter could not fully explain. Galaxy clusters held together more strongly than their luminous material seemed to allow. Gravitational lensing revealed mass where little light appeared. Dark matter does not shine or absorb light in ordinary ways, but it shapes cosmic structure. It is known by its effects, like wind known by moving leaves. Dark energy is even more mysterious. Observations of distant supernovae showed that the expansion of the universe is accelerating. The name dark energy is a placeholder for whatever drives that acceleration. It may be related to the energy of empty space, or to physics not yet understood. The night sky, therefore, contains not only known objects, but evidence of deep ignorance. Science is not a list of finished answers. It is also a map of honest uncertainty. Black holes are another place where the sky challenges imagination. A black hole is not a cosmic vacuum cleaner, but a region where gravity is so strong that inside the event horizon, light cannot escape. Stellar mass black holes can form from collapsed massive stars. Supermassive black holes sit in the centers of galaxies. They are invisible directly, but their surroundings can glow brilliantly as matter heats while falling inward. The darkness is defined by the light around it. The first image of a black hole's shadow came from the Event Horizon Telescope, a planet-sized network of radio telescopes working together. It showed a bright ring around the black hole in the galaxy M87, then later the black hole at the center of the Milky Way. These images are not like ordinary photographs. They are reconstructed from radio data gathered across Earth, synchronized with atomic clocks. The result is a human-made eye as wide as the planet, studying an object from which no light returns. Yet the night sky seen by eye remains calm. The black holes, dark matter, dark energy, gravitational waves, galaxy mergers, and stellar explosions are not obvious overhead. They hide behind points of light and dark spaces. This contrast is part of astronomy's power. The most dramatic processes in nature often arrive to us as stillness. The violence is real, but distance gives the mind room to receive it gently. The local group gives the Milky Way a neighborhood. Andromeda, the Triangulum Galaxy, the Magellanic Clouds, and many dwarf galaxies are gravitationally linked. Some dwarf galaxies are being stretched and absorbed by larger galaxies. Stellar streams around the Milky Way preserve traces of past mergers. A galaxy is not an isolated island, though it can look like one in photographs. It has history, companions, meals, scars, and future encounters. The future encounter with Andromeda is often described as a collision, but stars are so far apart that individual stellar collisions will be rare. The galaxies will pass through and around one another, their gas clouds interacting, their shapes distorted by gravity, eventually forming a merged galaxy over billions of years. From Earth, if Earth still exists in a recognizable form, the sky would change slowly into something magnificent. The future night sky is not fixed. The past sky was not fixed either. Proper motion changes stellar patterns. Precession changes pole stars. Supernovae add temporary lights. Comets appear and fade. The moon moves away slowly. The sun brightens gradually over billions of years. Constellations are temporary arrangements. Even the familiar is a phase. The night sky teaches permanence and impermanence at once. Old light, changing patterns. This makes a clear night feel both ancient and fleeting. The stars seem eternal because human lives are brief, but the stars themselves are born, age, and die. The constellations seem stable because our eyes cannot watch thousands of years pass. The moon seems always the same, but its orbit shifts and its surface accumulates tiny impacts. The sky is slow, not motionless. Its calm is the calm of very long change. There is also a biological night sky. Human sleep, animal migration, insect behavior, flowering rhythms, ocean navigation, and predator-prey cycles all respond to darkness, moonlight, stars, or artificial light. Dung beetles can use the Milky Way for orientation. Some birds navigate by stars. Sea turtle hatchlings move toward ocean brightness. Coral spawning can be tied to lunar cycles. The sky is not only above life. It participates in life. The Milky Way as a guide for insects is especially humbling. A galaxy of hundreds of billions of stars, seen as a faint band, can help a small beetle roll a ball in a straight line. Scale connects to behavior. The largest visible structure in the night sky can guide one of Earth's small animals across the ground. Nature is full of relationships that would sound invented if they were not real. Human beings also carry night sky biology. Circadian rhythms respond to light and darkness. The bright blue rich light of screens and lamps can delay sleep signals. Moonlight, firelight, starlight, and darkness shaped human nights long before electric lighting. Modern nights are brighter, shorter, and more interrupted than ancestral nights. The sky outside and the chemistry inside the body have always been connected. This is why a dark sky can feel restorative. Part of it is beauty. Part is scale. Part is the reduction of human-made stimulation. Part may be the ancient familiarity of darkness returning to something closer to its natural form. A person under a dark sky is not escaping the world, but entering a wider and older version of it. The mind can loosen because the sky does not hurry. Some nights are bright with the moon, and some are dark enough for the Milky Way. Neither is better in every sense. Moonlit nights reveal landscape, clouds, trees, roofs, water, and shadows. Moonless nights reveal galaxies, nebulae, faint stars, and zodiacal light. The sky changes its gifts. A bright moon hides some stars, but gives the world silver form. A dark moon hides the ground, but opens the deep. Binoculars are often the gentlest first instrument. They do not separate the observer from the sky as much as a large telescope can. They widen the eye. The Pleiades fill with stars. The moon gains texture. star fields become dense. The Andromeda Galaxy becomes more obvious. A simple pair of binoculars can make a person feel that the sky has moved closer, though nothing in space has changed. Telescopes add another kind of intimacy. A planet becomes a disk. Jupiter shows its moons. Saturn shows its rings. The moon becomes a landscape of craters and ridges. A nebula becomes a faint cloud. A globular cluster begins to resolve. Yet telescopes also teach limits. Many objects remain pale and subtle to the eye. The brilliant colors in astrophotographs often come from long exposures, filters, and processing. The eye's view is quieter, but it is direct. Astrophotography has changed how people imagine the universe. Cameras gather light for seconds, minutes, or hours, accumulating what eyes cannot hold. They reveal red hydrogen clouds, blue reflection nebulae, dust lanes, galaxies, star trails, and auroras in spectacular color. These images are real, but they are not the same as naked eye experience. They are translations. The night sky has many truthful appearances depending on the method of receiving it. Star trails show Earth's rotation visually. A camera pointed north records circles around the celestial pole. The stars are not circling Earth in the old geocentric sense. Earth is turning beneath them. But the photograph preserves the apparent motion. It turns time into arcs. A long exposure becomes a clock made of light. The same is true of time-lapse photography. The Milky Way rises. Clouds pass. Meteors flash. Airglow ripples. The moon floods the landscape. A whole night can be compressed into minutes. This compression is beautiful, but the slow original matters too. The real sky moves at the speed of the Earth. To watch it without compression is to join that pace. There are still things a person can learn by eye alone. Venus never strays far from the sun, so it appears as morning star or evening star, not at midnight unless circumstances are near transition. Mars changes brightness and color as Earth and Mars move in their orbits. Jupiter moves slowly among stars and can dominate a season. Saturn is steadier and subtler. The moon shifts eastward each night. Constellations rise earlier as months pass. The sky is a calendar that teaches by repetition. The ecliptic is the path of the sun across the sky and the general band where the moon and planets appear. It is not a visible line, but once understood, it organizes the sky. The zodiac constellations lie along it because planets orbit in roughly the same plane. Ancient astrology grew from attention to these paths, while modern astronomy explains them through orbital geometry. The same observed order produced different interpretive systems across history. Eclipses reveal alignment. A solar eclipse requires the moon to cross the sun from Earth's viewpoint. A lunar eclipse requires the moon to pass through Earth's shadow. These events do not happen every month because the moon's orbit is tilted relative to Earth's orbit around the sun. Only when the timing and geometry meet near nodes do eclipses occur. The rarity is not mystery. It is alignment. A lunar eclipse is especially gentle to watch. Earth's shadow slowly enters the moon. The bright disk dims and can turn copper red as sunlight filtered through Earth's atmosphere reaches the lunar surface. That red light has passed through the ring of all Earth's sunrises and sunsets. During totality, the moon glows with the color of the planet's atmosphere. The shadow of Earth becomes visible on another world. Solar eclipses are more dramatic and require eye safety, but their geometry is just as elegant. The moon's shadow touches Earth in a narrow path. Along that path, day becomes twilight, temperature falls, birds make quiet, stars or planets appear, and the sun's corona emerges. For a few minutes, the solar system becomes visible as a working machine. Bodies, distances, light, shadow, and motion all aligned. Meteorites add touch to the sky. Most meteors burn up completely, but larger fragments from asteroids or other bodies can reach the ground. A meteorite in the hand is a piece of another world, often older than Earth rocks at the surface. Some contain chondrules, tiny melted droplets from the early solar system. Some come from the Moon or Mars, blasted into space by impacts. The sky can fall, rarely, and become stone. Comets carry another kind of early solar system material. Their ices and dust formed far from the sun, preserving clues about the conditions in which planets formed. When a comet warms, it releases gas and dust into a coma and tail. The tail does not trail behind like smoke from a moving train in the simple sense. It is shaped by sunlight and solar wind. The ion tail points away from the sun. The dust tail curves more broadly along the orbit. A comet is a frozen archive made visible by heat. Asteroids are not merely failed planets in a simple way, but remnants and fragments of the early solar system. Some are rocky, some metallic, some rich in carbon compounds. Their orbits can reveal gravitational histories. Their compositions can reveal formation zones. Their impacts shaped planetary surfaces and occasionally life on Earth. A faint moving dot in a telescope can belong to a story of beginnings and catastrophe. The night sky contains human time as well as cosmic time. A supernova seen in 1054 was recorded by observers in East Asia and elsewhere. Its remnant is now the Crab Nebula. The light of Kepler's supernova reached Earth in 1604. The supernova in the Large Magellanic Cloud reached us in 1987. These events happened long before their light arrived, but they became part of human history when the photons reached Earth. Astronomy makes time layered. When people say that looking into space is looking back in time, it is not a metaphor. Light has finite speed. The moon is seen as it was a little more than a second ago. The sun, if it were visible, as it was about 8 minutes ago. Jupiter as it was tens of minutes ago. Nearby stars as they were years ago. Andromeda as it was millions of years ago. Distant galaxies as they were billions of years ago. The night sky is a time machine made of distance. Yet the experience is immediate. The photons arrive now. The eye responds now. The thought happens now. Astronomy joins ancient emission with present perception. The source may be old, but the seeing is alive. This is one reason the night sky feels so strange and restful at the same time. It widens the present until it contains other times. There is a final humility in knowing how much is not visible. Most stars in the Milky Way cannot be seen with the naked eye. Most galaxies require telescopes. Most matter may be dark. Most wavelengths are invisible to human senses. Most of the universe lies beyond the reach of unaided perception. And still, the few thousand stars visible from a dark Earth sky are enough to begin a lifetime of wonder. Limited sight does not make the view small. It makes the visible precious. There is also the quiet science of observing from a city. A city sky may hide the Milky Way, but it does not hide everything. The moon survives almost any light pollution. Venus can shine above streetlights. Jupiter can hold steady over rooftops. Orion, the Big Dipper, Sirius, Vega, and a few bright seasonal stars can still appear. Urban astronomy is not the full darkness of a desert or mountain, but it is not nothing. It teaches the beginning of attention under imperfect conditions. A person in a city can learn the sky by following the brightest objects first. The moon changes shape and position. Venus appears as morning or evening star. Jupiter shifts slowly among constellations. Mars reddens and fades over months. Saturn moves with a slower patience. The first lesson is not faintness, but return. Even under city light, the sky has rhythm. The same bright points come back, slightly changed, and recognition begins. There is a different kind of beauty in a rural sky. Away from artificial light, the number of visible stars increases until familiar constellations can become harder to find among the abundance. The Milky Way appears not as an idea, but as a structure. Dark lanes cross its pale band. Star clouds gather in Sagittarius and Cygnus. The sky gains texture and depth. The first dark sky experience can feel almost overwhelming, not because it is loud, but because the missing part of the world has returned. At high altitude, the sky may sharpen again. Less atmosphere lies above the observer. The air may be drier. The horizon may open. The Milky Way can appear more contrasted, and faint objects can stand out more clearly. But the body also feels the place: cold, thin air, wind, silence, distance from towns. Astronomy is never purely above. The ground matters. A mountain sky is also a mountain experience. Desert skies have their own character. Dry air, open horizons, and sparse settlement can create exceptional darkness. Stars rise from a low horizon with little obstruction. The Milky Way can stretch from one side of the sky to the other, while the ground remains a dark outline. In such places, ancient connections between sky and landscape become easier to understand. The sky is not a separate ceiling. It is part of the shape of the land. Ocean skies are different again. At sea, the horizon is circular, and the dome of the sky feels complete. Stars rise and set cleanly from water. The moon lays a path across waves. Navigation by stars becomes less abstract when there are no mountains, towers, or roads. The sky and sea meet along a line that moves with the observer. For sailors, the stars were not only beautiful. They were position, direction, and survival. The horizon itself is a scientific boundary. Near the horizon, celestial objects are seen through more atmosphere, so they appear dimmer, redder, and more distorted. The moon can look enormous when rising, though the effect is mostly psychological. Its angular size changes only slightly with distance. Atmospheric refraction lifts objects a little above their true geometric position. A star at the horizon is not seen through the same air as a star overhead. The sky has depth even before space begins. Scintillation also changes with altitude above the horizon. Stars near the horizon twinkle more because their light travels through a longer path of turbulent air. This is why Sirius, when low, can flash with vivid colors, seeming almost alive. The star itself is not changing from blue to red to white in seconds. The atmosphere is bending and sorting the light. The twinkle belongs not only to the star, but to the air between star and eye. Planets remind us of this difference because they usually shine more steadily. Their tiny disks average the turbulence over a small area, reducing flicker. Through a telescope, however, planets can shimmer and blur when seeing is poor. Jupiter's bands may swim. Saturn's rings may soften. Mars may become a restless orange spot. The atmosphere is part of every observation from Earth. It is both window and water. This makes space telescopes feel almost miraculous. Above the atmosphere, stars do not twinkle in the same way. Images can be sharper, certain wavelengths can be captured, and long observations can proceed without weather. But space telescopes are difficult, expensive, and finite. Ground and space instruments work together. The atmosphere that protects life complicates astronomy, and astronomy learns how to work around the protection. There is a quiet human lesson in that. The same air that blurs stars is the air that lets us breathe. The same atmosphere that hides ultraviolet and X-rays is the shield that keeps Earth's surface habitable. The same clouds that ruin an observing night bring rain. The same light that erases stars may make a street usable. Astronomy often teaches trade-offs. To wish for a perfect view is to remember why Earth is not space. The night sky also changes with age. A child may first see the moon as a face or a glowing object. Later, it becomes a world with craters. Later still, a record of impacts and tides. A teenager may learn constellations. An adult may find comfort in repeated cycles. An older person may see the same stars and think of those who once stood beside them. The sky remains outside, but its meaning changes with the person beneath it. Some astronomical objects become markers of personal time. A comet seen once in childhood may not return until old age. A lunar eclipse may be remembered by the place from which it was seen. A meteor shower may become linked to one summer. A planet bright in the evening may quietly mark a season of life. The sky is public, but memory makes it private. The same moon can belong to everyone and still feel personal. This is why sky watching can be restful even when the facts are enormous. The mind does not have to solve the universe while looking at it. It can simply receive. A star does not require an answer. The moon does not demand performance. The Milky Way does not ask to be understood all at once. The sky allows attention without pressure, curiosity without urgency, and wonder without noise. The final gift of the night sky may be continuity. Clouds come and go. Cities rise and fade. Languages change. Instruments improve. Theories are corrected. But Earth keeps turning, and the sky keeps returning in altered form. Not identical, not fixed, but faithful enough for memory. Night after night, it offers a beginning again. One star, one planet, one moon, one dark space between lights, and the possibility of looking longer. And perhaps this is why the night sky can hold both science and sleep so naturally. Its facts are immense, but its delivery is gentle. A galaxy does not shout its distance. A star does not announce its temperature. The moon does not explain its tides. Everything arrives quietly, as light, pattern, shadow, color, rhythm, and return. The mind can approach it slowly, gathering one idea at a time. There is no need to finish the sky. No one finishes it. Ancient observers did not finish it, and modern observatories have not finished it. Every answer widens into another question. What are dark matter and dark energy? How common is life? How do the earliest galaxies grow so quickly? What happens inside the most extreme stars? How many worlds orbit the stars that look so still tonight? The sky remains open, not because science has failed, but because reality is larger than any one generation of knowing. For rest, that openness can be comforting. It means the mind does not have to close every circle before night ends. Some questions can remain above us. Some distances can remain distances. Some lights can continue traveling. Some answers can wait for morning or for another century. The night sky has waited for human curiosity for a very long time, and it will not be impatient now. Imagine the Earth turning now. Somewhere, sunset is ending. Somewhere, twilight is deepening. Somewhere, a child sees the first star. Somewhere, a telescope dome opens. Somewhere, a fox crosses a field under moonlight. Somewhere, a satellite glides through dawn. Somewhere, the Milky Way rises over an ocean. Somewhere, clouds cover everything, and the stars continue unseen. The sky is not the possession of one observer. It is a continuous arrival. Light that reaches Earth tonight has crossed spaces no human body can cross. It has passed through dust, around gravity, across emptiness, through the heliosphere, into the atmosphere, through moving air, and finally into an eye. There, in living tissue, photons become signals. Signals become perception. Perception becomes thought. Thought becomes wonder. The journey of light ends, for a moment, as awareness. That may be the quietest wonder of all. The universe is not only large, it is knowable in fragments. A star can reveal its temperature. A galaxy can reveal its distance. A planet can reveal its atmosphere. A background glow can reveal the early universe. A simple human eye can see enough to begin. The night sky is not silent because it has nothing to say. It is silent because it speaks in light, and light asks to be received. As the night deepens, the sky keeps turning. Stars rise in the east and set in the west. The moon moves along its path. Planets drift through their slow stories. The galaxy arches overhead or waits below the horizon. The universe does not pause. and yet from the ground it can feel perfectly still. This is the paradox that makes the night sky so gentle. Motion everywhere, peace in the seeing. If the sky is clear tonight, perhaps only one star will be visible from where you are. Perhaps many will. Perhaps the moon will be bright, or perhaps the night will be dark. Whatever appears is only the nearest layer of a much larger reality. Behind the first stars are more stars. Behind the Milky Way are galaxies. Behind the galaxies is the oldest light. Behind every answer is another horizon. And here, on this small turning Earth, under atmosphere, under time, a person can simply look up. No instrument is required for the first step. No perfect knowledge is required. The sky is generous to beginners. It allows a glance, then a longer look, then a lifetime of learning. It holds physics, history, mythology, navigation, chemistry, mathematics, and memory, all arranged in darkness. The night sky is not empty. It is full of old light, moving worlds, hidden dust, stellar births, stellar deaths, ancient clusters, distant galaxies, invisible waves, and questions still open. It is also full of quiet. The kind of quiet that does not mean absence, but depth. The kind of quiet that lets the mind loosen its grip on the day and remember that it belongs to a universe older, wider, and more patient than any single thought. The stars do not need human stories, but human beings often need stories to remember the stars. A pattern becomes a hunter, a bird, a river, a cross, a bear, a canoe, a scorpion, or a swan. Later, science adds spectra, parallax, mass, luminosity, and age. The story and the measurement do different work. One helps the mind remember a place in the sky. The other helps the mind understand what that place contains. Together, they make the sky both intimate and true. The more one learns, the more the night sky stops being a flat surface. The moon is near. The planets are close compared with stars. The stars of a constellation are scattered in depth. The Milky Way surrounds the observer. The galaxies beyond it are separate systems. The cosmic microwave background lies behind ordinary sight. Learning astronomy is partly learning to add depth to a dome, to turn a ceiling into space. Even cloudy nights belong to the same universe. The stars are hidden, not gone. The moon may soften behind vapor. City light may color the underside of clouds orange or silver. Rain may fall from the atmosphere that normally carries starlight. A person does not see the cosmos every night, but the cosmos does not depend on being seen. It continues beyond weather, beyond sleep, beyond attention. The night sky can also soften the idea of solitude. To be alone under stars is not exactly to be alone. The body is with earth, atmosphere, gravity, and light. The eyes are receiving old photons from many directions. The mind is linked with generations of people who have looked upward before. Solitude under the sky can become a form of company, not because the stars are conscious companions, but because they place one life inside a much larger continuity. The quiet of the night sky is not the quiet of emptiness. It is the quiet of scale. Many of the events overhead are enormous, but their distance turns them gentle to the human eye. A star may be a nuclear furnace. A galaxy may contain hundreds of billions of suns. A nebula may be wide enough to swallow the solar system many times over. Yet from Earth, they arrive as points, patches, and pale bands. Distance transforms violence into beauty, and time transforms brightness into memory. There is also a kindness in the fact that astronomy can begin without ownership. The moon cannot be bought by the person who looks at it. Sirius does not belong to one country. The Milky Way crosses borders without noticing them. The sky is divided on maps for convenience, but light itself is not national, private, or fenced. It falls wherever the horizon allows it. In that sense, the night sky is one of the few great commons still visible above us. even where artificial light has made it harder to receive. The last quiet thought is that the sky does not need to be solved all at once. It can simply be received. One star, one moonrise, one faint band of the Milky Way, one planet above a roof, one meteor crossing and disappearing. Astronomy can become vast, mathematical, and technical, but it can also remain as simple as attention. A person looks up, the light arrives, and for a little while the mind is allowed to be smaller than the universe without feeling lost inside it. Sleep well. Good night.